Good day, everyone, and welcome to this next episode of the Industrial Innovators Podcast. I'm Don Cooper, as you know. Today, we're going to be talking about API 653 and its recent changes that allow for API inspectors and API above-ground storage tank owners to leverage new repair methods that are really going to help you transform your tank strategy going forward. Today, I've got special guests from our partners at HJ3. Ollie and Dominic are here. They are way smarter than me about composite repair and about tanks. And so really this conversation is going to be about them sharing their wisdom with you. And so Ollie and Dominic, welcome to the show.
Thank you so much.
Yeah, thanks, Don. Appreciate having us on.
So before we dive into everything, quickly tell the audience your roles at HJ3, if you wouldn't mind, starting with Ollie.
All right, so I'm Vice President of Quality and our Senior Applications Engineer. I've been at this for about 20 years and worked with the API committee to get carbon fiber approved for storage tank repair.
So you've been intimately involved in API 653 changes.
Yeah, definitely. About 2016 and got it approved in 2020.
Yeah, it's a long process. I've got similar stories to tell around the piping side, specifically here in Canada. We'll dive into that as we chat more. But this is about tanks and about API right now. So Dominic, how about you? What's your role at HJ3?
Yeah, Don, I'm the Vice President of Sales. So I've been with HJ3 for about a decade now. And over those past 10 years, helped spearhead different types of projects, whether it be in the general industrial space, food and ag, oil and gas, but a lot of tank applications, which, has resulted in us, Ollie and I working together to create these designs and implement these solutions on hundreds of different projects across the world.
Awesome. Tell me about HJ3. What do you guys do, and how did you guys get involved in tank repair?
Yeah, so HJ3 got its start in 2002. It's founded and owned by Jim Butler, our CEO. We're a manufacturer of composite materials. We provide engineering according to the latest design standards in concrete, steel, and other different structures. We provide support, training for certified installers, and we have a manufacturing facility headquartered here in Tucson, where we make our own polymers, our resins, and our different carbon fabrics.
And specifically around tank wrap and tank repair, how did that evolve?
Yeah, so we were approached by a client at a pulp and paper mill. They had a high density stock tank that was severely corroded. They had a 3-year replacement plan. Long story short, after an inspection, revealed that the shell had significant corrosion. They needed a repair that could allow them to stay online during the repair and get them from point A to point B. So that was December of 2004, and that was the first above-ground storage tank that was repaired with carbon fiber. Since then, we have worked with the design committees to implement the standard and to continue the advancement of the technology for above-ground storage repair.
Okay, so that talks about, the authorities involved. We're talking about the American Petroleum Institute, and specifically the API 653 group and Annex J, the changes that have happened relative to API 653. Can you tell me about your involvement in that process, what it is for the listeners?
Absolutely. So we had reached out to the committee in 2016, and we were showing them examples, case history where carbon fiber had been successfully used to repair storage tanks. And we put together a technical proposal that later it evolved into what's called a letter ballot. A letter ballot is submitted amongst all the API SCAS, that subcommittee on above ground storage tanks. And it went out. We got a lot of feedback from owner operators, from inspection companies and engineers, with considerations and technical concerns they wanted addressed in order to utilize the carbon fiber material for tank repair. Prior to that, tank repair had been limited to welded plates, And there are pros and cons of doing steel on these applications, as we'll get into. But after they saw the technical proposal, the case history, the calculations required, that letter ballot found its way into Annex J in its entirety. Annex J specifies the unique criteria for using carbon fiber on tanks, things like flammability, additional testing that's required, as well as environmental reduction factors that would be applicable for long-term repairs in storage tanks.
Sounds like the journey is a lot like what we experienced with piping repairs and composite in Canada. We made a commitment as one of our 3 big objectives when we started Innovator to get composites recognized by pressure authorities, because it was a Band-Aid here in Canada, even though there was already precedent with ISO standards and PCC2. Here in Canada, we have this layer of local pressure authorities that actually license and provide the guidelines for how everything is done. And there was no guidelines, and so they weren't really approved repairs. So composite in Canada was used by maintenance teams as Band-Aids and patches, and it developed a really bad reputation.
Yeah.
Because of bad installs, because of they were non-engineered, they didn't have surface prep, they didn't have good quality control, they didn't have certified installers. And we had some legacy composite providers who were just selling kits to whoever had the POs for them. And I wrote an article that said why composite got a bad rap, bad reputation.
That's right.
And it was because of the way that it was utilized, and it was unregulated. And that was actually the premise for getting more people on side. Unfortunately, it took a long time, as and I'm sure you've experienced this with API. We started off by trying to treat composites like we did with other leak repair enclosures, engineered catalogs, submit for review. And, our initial response from the pressure authorities was, nobody wants this. And I'm like, and there was a bit of a bias because we're a contractor trying to get something approved. Their sort of biased view was we're trying to do this for our own commercial advantage. And certainly that's part of it. We wanted to create business. But what really struck me is they said none of the chief inspectors with our clients have ever asked us for this, and they don't want it. And my response was, well, they keep asking us for it and asking when we're going to get it approved. And so we had to pivot, and we created a working group of all the industry that really lobbied the local pressure authorities, and that started to really build momentum when industry stakeholders got involved and said, here's what we want, here's what we like, here's what we don't like. But it still took us, again, I started this sort of journey in 2009, and we got the legislation changed for piping in Canada in 2020, similar to API 653. From a compliance standpoint, give me a sense on what tank wrap, can do for repairs and storage tanks, and what are its limitations?
Yeah, that's a great question. So, the most common problem that tank wrap is going to address is going to be corrosion. So corrosion in the shell, which causes thinning. And after you run calculations, we can determine if it's sufficient or not. If the shell is not sufficient alone, then the old way of doing it would be to weld a plate or cut out a plate and do an insert plate. With tank wrap, we can provide that same structural strengthening for those hoop loads caused by hydrostatic pressure that's inside of the tank due to the liquid height and what's in the tank. So we can do that externally or internally. Each has its own pros and cons. And some of the limitations around where we can use the standard, we can't use it in the bottom 12 inches of the tank for a compliant repair. So that's called the critical zone. There's a lot of forces acting there. It's not just tensile in the hoop direction. You get a lot of different things. So we stay out of that zone when we have a strict code compliant repair. But things like holes, corrosion, external pitting, internal pitting, gouging, issues with welds, all of those things can be repaired as long as we are providing a design for the hoop stresses, the tensile loads.
Yeah, and the other thing that's nice about it is that you don't necessarily have to treat the whole tank, because one of the things we see a lot is that more often than not, people do these inspections, they find these issues, and they say, well, this is beyond repair. We're going to replace it in 2025. But the reality is, and what we see a lot, is that it's really 20 to 30% where these issues are focused, where I always ask people, you're talking about throwing away 100% of a tank when only 20% has a problem. So when you introduce this concept to people that we find really aren't aware of it, it really opens up a lot of opportunity and capabilities for them to provide this rehabilitation in situ. You don't have to take it offline many times, and you can save a ton of money versus trying to tear this whole thing down and rebuild it or weld plate or do all these things, when you can introduce this composite membrane to provide that structural strengthening for the wall loss due to corrosion and those other defects.
So I suppose another big benefit, I heard two really key things in there. One is all the external, obviously the internal repairs, the tank has to be drained and cleaned and there's tank downtime, but all the external repairs, can these be installed and utilized without taking the tank out of service?
Yep. Yeah, and you can elaborate on it some more, but there are, when we do the design, and again, Ollie can speak into this much greater on his end, but when we look at the design of it, there's a point at which it is allowable to do externally without taking this tank out of service at all, right? And you're in that preventative maintenance position. Right. The harsh reality, though, is that a lot of people will drive these things to a point that, they will have too much wall loss and things of that nature. But there is about, 50% of them we can do while in service and online, and then having this additional option because people just don't know it. They get their annual inspection report. They say, hey, we'll do it again next year, and then we'll keep going until we have a problem. But when you can implement this, proactive solution, you can save a ton of money. And I think I can tell you more about when you can implement it when the tank is in service.
Yeah, so as Dominic was mentioning, tanks are run to get the most service out of them as possible. Sometimes that means that they're ran in a state where they're already structurally deficient. And in those cases, the steel itself is actually close to its strain limit. And with carbon fiber, we have to set the strain equal to that of the steel. So that means they're acting in unison. Sometimes tanks that are filled up to the top, that the shell core steel will already be at its strain limit. So if we lower the liquid line a bit, then we can relax the steel, we can apply the carbon fiber, let it cure, and then fill the tank back up, so that all of the integrity is restored.
Okay. So now, it really depends on what your engineering analysis determines. The approach in terms of execution, in terms of lowering levels or draining or leaving it in play, is really going to be on a case-by-case basis.
That's right. And if there are active leaks at time of installation, all of those have to be patched and repaired so that everything is dry prior to installing the tank wrap carbon fiber system. So all of that has to be executed. And, I would say our greatest feedback, our most positive feedback from clients is that we can provide an external repair system without damaging the internal liner. So with a welded repair, that's going to create a lot of issues. It could destroy the internal liner, leading to further corrosion. And it can also create a heat affected zone around that weld. And that heat affected zone will capture a lot of residual stress. And eventually that will want to come out over time. So if you're in a very active state of corrosion, that residual weld stress will start forming different cracks and other defects that aren't good. So the carbon fiber being a cold repair, meaning there's no heat generated, it's a simple surface prep, that's going to provide the greatest impact to the client, keeping the tank in service during the repair and keeping that internal liner intact.
Awesome. So back to Dominic, you were talking about clients often making a decision to potentially completely replace the tank when in reality it's got defects over 20 or 30% of its area. And now, and then in the past, they've made that decision probably from a paradigm of, if I've got to replace 20 or 30% of the panels, then I might as well replace the whole tank. So that's probably how they come to that conclusion. But with this repair method, all of a sudden faced with 20 or 30% repairs, you could extend the life of the tank, have a different strategy with your capital expenditure and your repair plan on tanks. There's a lot of benefit, I think, in terms of helping people, get way more value out of their tank budget. Not just their capital budget, but their maintenance budget, and do more with in one way, do more with less, or do more with the same budget, leveraging carbon fiber tank repair.
Totally. Yeah. I mean, when you can address those isolated areas, not only are you boiling down the scope, but you're significantly de-risking the project as well. We see it all the time where people have plans, and a lot of people do these, and more power to them. But hey, in a 1 week outage, I'm going to tear down this 1 million gallon tank and I'm going to put this new one online, or I'm going to replace this vessel, or whatever it is. They have these lofty goals. And again, there are experts that do those things, but there is another option. And again, not a lot of people know about it. So part of the process is to educate them so they understand that, look, you don't need to do all that. We can provide you the same longevity of a replacement, if you will, because these are 20, 30-year repairs. It'll also provide the corrosion resistance you need. And it's a lot less risky. You don't need cranes. You don't need all this, trucks of steel. Don, you and I could move 300 square feet of carbon fiber in a box. The three of us would struggle and, get everyone we know to move a big old 30 by 10 plate of steel, right? So when you have this concept, I think the struggle is that it's so different to people, right? And I appreciate having the opportunity to talk about it here, because it's something we've done a lot, like Ollie mentioned, for 20 years, because this can save so much time. It can reduce risk significantly when you remove the machinery, and like you said, really optimize capital budgets and outage schedules. Time is money to customers. They can't extend outages 1 week, 2 weeks, a month. And so making sure those schedules are hit and hitting these critical path projects, which these typically are, saves people a ton of money and a ton of headaches.
Yeah, I mean, I think you touched on two key things, right? Totally changes the risk profile of the project in question, and totally changes the critical path nature of the project that they undertake. I mean, traditional tank repairs inside of a facility are major critical path projects that have impact on marketing and production and downstream servicing, and this is a total shift in terms of their, can be a total shift in terms of their tank strategy.
Yeah, absolutely. And, the other part of it is the value engineered approach that we take. So when we have a condition assessment report with many ultrasonic thickness readings, we know each and every location where the tank is deficient or it's actually above the required minimum to handle what's inside of the tank. So with tank wrap, we refer to it as a very scalable repair material, because we can simply add another layer until we reach the desired goal. So in one area of the tank, you may have your base 2-layer system. In an area that was severely corroded or has more demand from a tensile capacity standpoint, we can simply add more layers in that area. And so that really lowers the overall cost of the repair and allows the client to see how we can get the problem addressed for each and individual location, as opposed to a broad brush where we say, hey, let's rip out that course and we'll install a new one.
Right. So listeners are probably familiar with PCC2. In Canada, we've got the derivative of the ISO and the PCC2, which here in Alberta, it's called AB539, which is just the legislation of how those international codes are applied in our jurisdiction. But they're probably less familiar. I mean, there's lots of listeners that are familiar with API 653, but not in the context of composite repair. What's the difference in terms of qualification, or the similarities with qualification with API 653 and say PCC2, just to kind of provide the bridge for helping people understand one approach and now how it's applied here.
Yeah, definitely. So PCC2 outlines the material testing that's required to qualify your system. So these are things like tensile properties of resins, tensile properties of the composite, lab shear, shear modulus, bond adhesion, things like that. Well, for API 653, instead of having a 5 specimen minimum for testing, the committee wanted at least 20 samples. And that's because they wanted at least a 99% confidence level in the design value of the material. So if you've done PCC2 qualification testing, you're going to have to do additional tests to show that you have at least 20 samples. In addition to the material side, we still do the burst tests. So AB 539, ISO 24817, and ASME PCC2 have outlined pressure tests where you can demonstrate the repair system's ability to handle pressure if, let's say, your wall loss is 80%. We also do the same level of testing for energy release rate, which is that value that you achieve when you test the carbon fiber over a through-wall defect. So it could be a 1/4 inch, 1/2 inch, or 1 inch hole. All of that is still required. Now, some of the other requirements is if the tank carries a flammability rating, let's say through NFPA 30, for dissipating static away from the tank, the composite system will have to have the ability to dissipate static. And most composite systems, even if they're carbon fiber, will still insulate, meaning that it'll retain static and it will not send it to a grounding source. So that creates an issue for the potential for static ignition and an explosion in a flammable environment. So the API committee wanted the additional criteria for how the system will handle a fire event, how it can dissipate static to a grounding source, and how it would perform in a fire in terms of flame and smoke spread. Obviously, any material you put on a structure, it has to be tested, and we want to understand that a fire isn't going to get worse with the repair system, and the fumes and smoke that it's generating, we don't want to endanger the fire fighting personnel in that process. So those are some additional tests in addition to the PCC2 and ISO AB 539 requirements.
What I heard is more stringent.
Yeah, definitely.
Right? Higher levels of confidence. I mean, five samples versus 20, addressing some unique characteristics of tanks around static discharge and fire. I think that just can speak to the level of confidence that tank owners and API 653 inspectors can have that in a lot of ways, the application here takes what they might have already seen on piping to another level.
Absolutely. And I'll mention another key difference. The committee, looked at tank repair with composite materials, a long-term repair. These aren't just 2-year repairs where you're going to take it out and replace it. So they wanted to look at how each individual system, whether it was carbon fiber, fiberglass, or a Kevlar system, would behave in an aggressive environment. So we had presented testing that was performed on our systems, 20,000 hours of accelerated durability testing in low pH acidic conditions and high pH caustic conditions. And what we found and what others have found is that carbon fiber retains a significant amount of its original strength, whereas fiberglass and Kevlar have a certain time point where they hit and they start wicking in the chemicals that they're exposed to. So as a result of this testing, carbon fiber can use 85% of its strength. So there's a 15% reduction factor for long-term repairs. Kevlar, on the other hand, has 70% utilization. So it has a 30% reduction factor showing how it performs in these aggressive environments. But fiberglass had a 50% reduction factor in long-term service. And the reason for that is fiberglass and Kevlar have an ability to wick in material. So as it wicks in chemicals, it'll start undermining the composite matrix much quicker. Carbon fiber doesn't have an ability to wick, so it tends to perform a lot better in long-term durability. So those are the other key differences on the design side, making sure you're using the right environmental reduction factor based on the fiber you're using.
Right. So with that reduction factor, I'm just trying to understand its impact. So will that impact the life expectancy of the repair, and or does it impact the amount of material that you have to use, or is it both?
It's going to be both. Any system that's selected, part of the design criteria is to compare the surface temperature, the chemistry with your long-term testing. And some chemistries and temperatures are just not compatible with composites. So you want to look at how your testing is in, just immersion, looking at coupons and samples, but also how it retains strength. So those are considerations on selecting the system. Now, if you are using a fiberglass system, you're going to end up having to do about twice as many layers as you would in a PCC2 or piping design. And that's because you have a 50% reduction factor on your design values in the system.
Right. So shorter life and more material to get there. So
that's right.
That's right. Which
sounds like carbon fiber is the way to go on this on tanks.
Yeah, definitely.
Yeah, it saves you a ton of time on the install as well. That's the other piece of this is the speed at which you can deploy it.
Yeah, I mean, we've always found that with carbon fiber is that the person hours and the schedule time leveraging carbon fiber over fiberglass was significant. Even though the material itself was probably a bigger investment, the overall project was more cost effective using that better material. So
right.
when it's the right application. Let's dive into what are some of the types of repairs that are possible with a fully tested system. Like, what can you tell me about, what's possible and what are the pros and cons of each approach?
We can do an external repair that can be over a small localized area. So if you have a through wall defect, the rest of the steel around it's good, you can simply put on a structural patch. That also requires calculations in the same approach, but it's limited in scope and size. We can also do an entire shell course. So usually at the liquid line, we encounter a lot of corrosion due to the oxygen and how that liquid is behaving. So, we may have an entire course that we end up wrapping, or we can do an entire wrap if it's strictly code compliant. We're staying out of the 12-inch critical zone at the bottom. But though, that's the different, we talked about the scalability of the repair. We can go from very small to very big, depending on the actual needs or problems in the tank. Now, the disadvantage of an external repair is that if you have internal corrosion, you're going to have a limited life of that repair. Because as the internal corrosion progresses, that steel may reach a point where there isn't enough structural integrity to handle the non-tensile loads like wind, seismic, dead loads from the tank. Now, the same type of system configuration can be used on the inside, and the benefits of that approach would be you're getting the structural integrity as well as the protection. So we can stop what's going on with the internal corrosion. We can restore structural integrity with the tank wrap system on the inside. The only downside, of course, is that you're having to drain the tank and you have a repair schedule where that tank will be completely out of service during the installation of tank wrap.
Okay. So if an owner inspector has a storage tank and that requires shell strengthening and they're considering carbon fiber, what do they got? Where do they start? What's next?
I think once they have the data collected to, understand the problems, kind of where that begins, right? So once an inspection is conducted, you truly know what the problems are, right? So that's kind of step one, understanding where you're deficient, what your deficiencies are. But then number two is to understand what is the objective. Some facilities have a useful life, horizon. Some facilities are trying to make it, as Ollie mentioned, A to B position. It's 2023. This is already slated for replacement in 2025. So really understanding, what the issues are, and what do they want to accomplish, because that informs how we can create this value engineered solution. Because every single project we look at, we take that kind of tailored approach, right? We're not just going to say every time, hey, let's wrap the whole thing in tank wrap, right? And I think some of the people may do that, but where we like to really get into the nuance and the details is, again, understanding those objectives, because those are two different types of situations, right? The 20-year fix versus the 1-year fix. So once they have that understanding of the problem and the resolution they want, we can help them fill those gaps in the middle there. Yeah. And so that's what we're doing on a day by day, week by week basis with customers all over the world with these tank wrap designs and deploying those repairs.
Yep. So an owner operator will send that condition assessment report. If there's photos of the tank, we'll take those as well. And the most important piece is the engineering assessment form. That's a 2-page worksheet that gives you the data, the basics around what's the diameter, what's the height, what's in the tank, and what the different shell course minimum thicknesses are. With that level of information, our engineering team gets started using a software that we built to design the system according to API Annex J. And that's going to include a full calculation report specifying the owner-operator location, the project information we've received, and after many equations, we will make a determination on the required layers to bring the shell of the tank back up to its structural capacity.
And so point there would be that.
Go ahead, Don. Go ahead, Dominic.
I was saying just yeah. Sorry about that. I think also getting into the nuances of the scheduling that's available, kind of what you talked about earlier and touch on a bit there, is that internal versus external repair, right? That's a really big component of what is allowable. Another thing is if there's any kind of welding or hot work allowed, right? We see a lot of times where there's not a welding outage scheduled for a significant period of time because of intrinsically safe environments or processes. And this can be done, again, without any kind of generation of sparks or hot work. So understanding all of that will go into the equation of the appropriate repair design, the number of layers, and where it's going to go in the end to either be that external application or that internal kind of 2-for-1 where you're getting the protection and the strength together.
Right. So if you think about it, just trying to summarize what I heard, you're going to have an engineering review sheet. You're going to have the API inspection report. They're going to have some sense on what are they trying to accomplish? What's the goal here? Potentially even identifying what they can't do, like, hey, we really don't have a window for hot work. We need to do it. What are the other alternatives? And then gathering sort of the beginning with the end in mind, with the objective and what they've found and the data comes back to you, and then you design a solution that matches that and potentially come back with some options for the client, including the repair window of when they want to accomplish it.
Yeah, okay? Exactly.
That's right.
All right.
Sorry, Don, to add one more piece there that's important as well is the timeline for implementation. Right. That has become very critical in a lot of projects we've seen over the years. Is they may want to replace it, but they want to do it in such a time that's not allowable. To manufacture a new tank, or if it's stainless or something like that, that can be 18, 24-month lead time. As a manufacturer of this in the United States, we can react very quickly and do a lot of bulk production, that we can produce the amount of material required for a lot of these things in a matter of days, not a matter of months. So that's another piece that comes down to this of, they may have a solution in mind and they may have been planning on it and budgeting for it, but the problem worsens such to the point that they have to do something different. And that's where we can help a lot of people solve those problems in a quick manner.
We see that a lot with clients, on piping projects where they've been monitoring wall loss, whether that's internal or external. Normally, what they can't control is a lot of internal corrosion and erosion things that seem to have a life of their own and sometimes accelerate. And all of a sudden, they thought they had 6 months or a year, and now they know they've got 2 months, or they're going to have to shut the system down. And I carbon fiber and composite repair is, particularly now with all of the code recognition of it, provides this whole new way of dealing with those unexpected realities, right? Which is what they are.
Yeah.
Unexpected realities and also requiring a solution as soon as possible. I mean, as you know, this industry lives and breathes on response time. So once we get this information, our commitment to our certified installers and owner operators, we provide a same day calc, which includes a quotation on material and shipping. And if necessary, we can also provide a same day shipment. Being a manufacturer of material, we have a significant amount of inventory, and we are producing everything in bulk, and then it's packaged into easy to use kits out in the field.
So, deepening into the process, and we're talking about actually installing the repair. Tell me about who can do this. Like, what's the certification process? Can mom and pop tank farm maintenance team just jump on this, or do you have a different process?
Yeah, so part of the requirements from API, we have a section for installer qualifications, and installers just by trade have to have experience with surface prep, experience with mixing polymers, saturating fabrics, applying these different composite systems. This is in addition to all of the mechanical requirements that these types of certified installers will carry. So the certification process is good for 3 years, and we start out with classroom education, going through what is the technology, how does it work, what are the products being used, and in that we identify the types of repair. So whether it's leaking or non-leaking, whether it's external or internal. And then we also review the environmental health and safety requirements of using these types of materials. So what personal protective equipment is required, as well as how to dispose of the product in compliance with your state, local, and federal law. So that's, a kind of a brief snapshot. Where we really spend a lot of time is on the quality control and quality assurance. So we have, new tools that aren't common in every industry, things like a Shore-D hardness reader for detecting how much cure the composite repair system has. We use a lot of environmental controls on site so that we monitor the humidity, the dew point, the ambient air, the skin temperatures, making sure it's all within the required parameters. Now, we do spend a lot of time teaching our certified installers about the requirements for surface prep. What level of anchor profile pattern needs to be built for this high strength composite to actually transfer its strength into the substrate. So, it's a detailed course. And then we also have a hands-on educational training that we actually walk the technicians through the installation, starting with surface prep, the environmental controls, installing the primer, the filler paste, the carbon fabric, and that specimen is then sent back to us, and we actually will hydro test it to make sure that their installation has met the minimum requirements for a good system installation in the field.
And beyond just the technical aspects of qualification, we also support on the logistical implementation side of things. It's not an easy thing to put on some of these tanks that are very large scale. You're talking 20, 30,000 square feet of product going on there, right? So it's not like any, as I might call them, Joe Carbon Fiber can pick it up and stick it on there, right? You need to have really an understanding not only of all the nuances associated with the design, the surface preparation, but how are you going to attack this thing? And how are you going to deliver a solution that's very technical and very precise in the schedule in which you committed to, right? So our, 2 decades of experience in this market also helps inform that of, okay, on this project, this is how you're going to do this to make sure that you're going to hit that required timeline. You need this much manpower. You need to set up here. You need to move your material around this way. All of that stuff goes into the qualification and the training to make sure that the applicators are capable to handle these kinds of repairs as well.
Right. So, we're talking about classroom training, practical training, inspecting what you expect in terms of test coupons from certified installers. And what I heard here, one of the things we do with our installers is beyond the training and certification, we then have a buddy system along with all the procedures and all the skills where they've got to do field competency checks against each other. So we just sort of create this robust set of evidence that they are consistently applying what they know, what they've learned in an appropriate way with competent people by their side. But on the last part that you mentioned, Dominic, that I think is different than what I've seen from all other composite developers and suppliers, is you're taking your experience in tank repair and then bringing wisdom in terms of project management and planning, which is not normally what happens with piping repairs. These are larger projects that require, I would say, a higher level of elegance and sophistication than I've got 10 feet of pipe that I've got to wrap.
Totally.
That's right.
Similar methodologies and systems, but the project complexity is at a higher level. And this isn't for someone who's just learning how to do composites to try to take on. This takes both, I think, a lot of experience on the contractor side and leaning into your experience on the project planning and project management, because I think without that, I wouldn't want to be doing the first tank project without that level of project wisdom.
Yeah, totally. Because I think, Don, I mean, I don't know how many hundreds of thousands of miles of pipe you wrapped, right? But something different can go wrong every time. And knowing how to handle those situations is something that's super valuable. So that's the thing, is that while the technology may be similar, it's actually very different in how it's installed. You're talking about a effectively flat vertical surface rather than a circumferential, pipe that you can develop right onto. How you lay it up, how you sequence the team, and all those things are, again, all massive considerations that you need to take into account here. And so, that's something that we do try to go above and beyond. And like we like to say, is be there through repair, not just helping you understand the project, understand the solution and the design, but how are we going to see this through together to make sure that this repair does exactly what we said it would do as a team collectively. So we try to keep that touch on every single project that we do, especially ones of this magnitude.
Yeah, and finding balance and high productivity while maintaining quality, I think, is something that you just develop over time. So to your point, Don, this is not something to look down a catalog and say, oh, carbon fiber tank repair, I could do that. It really takes some thought, some consideration for providing high quality installation within the allotted time in your project.
Sounds like tank wrap's got a sweet spot, and that can really provide. To me, it's not just additional value. I think, at least for our clients and our listeners, this is a paradigm shift in terms of what's possible that they've never considered before, particularly considering that they've normally turned to traditional welding as their approach, or replace the entire tank and tear down. So once a client, decides they want to move forward with a contractor, how does the process sort of grow that from, design intent all the way through installation?
Yeah, I can definitely speak to that. So once we've, done all the steps like you mentioned, understand the problem, what the solution needs to be, and when it needs to be deployed, right? And we say go, now we get into the piece of delivering on the promise we made, right? So first off, we want to make sure that the timeline is very critical. So when does the material need to be where it's supposed to be, right? That's what's going to drive most of it, manufacturing and logistics. But then while that's happening, in conjunction with that is we do designs and engineering for each project. But then beyond that, we also supply shop drawings. And when you're getting into these repairs where it's just, hey, on the third course, you need to do from 210 feet circumferentially all the way down to, around a 233 and it's 2 feet wide, or, I guess I should speak a little bit in metric too, but that.
Well, I speak English.
Okay.
Well, Canada is a funny place, right? I mean, I grew up at the beginning of my life, it was the imperial system, and then they introduced the metric system, but it's never been one or the other. It's kind of this strange hybrid. But but we often speak in inches and feet and pounds
Okay.
but depending on who the engineering firm is with the owner, sometimes you'll get millimeters and Newton meters, and sometimes you get both. I've worked on
Combination.
I've worked on 24-inch flanges that took 600 PN gaskets. So.
But the detail associated with each project is very important. So we map that out, and then we work through the schedule, to deploy that and repair it, right? So when is the material going to arrive? Where's it going to go? Where's it going to set up? How are we going to stage? Especially in cold weather climates, what's the weather protection plan? How are we going to protect the asset? Where's the material going to be, saturated? Where's it going to be installed? All those things are kind of like the step-by-step process. And then once you get into the repair itself, again, which is after many steps already, then it's the QC and monitoring of the application to make sure, again, it's going where it needs to be. The drawings also include a shading process, if you will, to show progress on a day-by-day and shift-by-shift basis. So traction isn't lost as you're working through the schedule. So that's how we try to make sure that we're working through every single step, from manufacturing to scheduling to QC on every single project. And then finally closing it out and being there once you put it back in service to make sure that it's online, it's doing what it's supposed to do, whether it be an internal or an external application for every project there.
I've said this before, but one of the things I like about HJ3 that I've seen different, and I've worked with every single composite company out there over the last 20 some years. And, they're all great at designing materials and testing materials. You guys have a practical side to your business that really, for me anyway, really speaks to the credibility that you're not just building, designing solutions and supplying material, but you know how to do it. Like, you know how to plan and execute the project. I don't see that. In fact, I've never seen that when it comes to the composite supplier sort of bucket. I think it's refreshing for me that you guys have such a comprehensive process from all the way that you're designing and testing the materials and making sure it is done in collaboration with the code authorities. But then you have a real common sense project management approach of, we got to make sure these projects get managed and executed on schedule, on time, meeting customer expectations, all while focusing on progress reporting and quality control. Yeah. So many of those things in terms of what I see, particularly on piping, is there's a torch passed. I did my part as the supplier, you do your part as the contractor, you do your part as the owner. It just feels that this is much more collaborative and succinct. Yeah. It's impressive, it's comprehensive. And it's from start to finish. Yeah. So let's talk about the longest repair. Like, what have you done so far in terms of the longest in-service tank repair?
So that goes back to the fall of 2004. We had a pulp and paper client. They were desperately searching for a repair that would allow the tank to stay in service. They knew that welded repair would take them out of service. They knew it would compromise internal lining. So they kind of did a Hail Mary last-ditch effort. They ended up finding us online, and they said, hey, we know that carbon fiber works for concrete, which we were heavily involved in at the time. Could it possibly be used for our structural tank repair? So we reviewed it with our design team. We said, to really be certain about the applicability and feasibility of this repair, we need to send a team out. That team collected UT thickness readings. They were able to see what was going on inside the tank as well as outside. And in the process, detailing out nozzles, vertical supports that needed special detailing. So that data came back to our design team. The engineers looked at it. They applied some rules from ASME PCC2, which was in a draft state at that point. We also looked at just, simple Barlow's equations, and most importantly, the API 653 standard for calculating shell thickness minimums. So we put together a package. The engineering looked great. We provided drawings. The overall price tag looked good from the client from an installed perspective. And they said, look, if this really works, we're going to need a stamp repair and we need to get going right away because we need 3 years out of this repair. We need to get to 2008. We've already planned to take the tank out and replace it with something new. And somebody, made a great insight at that time and said, look, we have internal corrosion. If we were to do an internal lining at the same time during this repair, we would essentially stop the corrosion on the inside while adding structural integrity to the external portion of the tank. So that's what the client elected to do. This project, started out with abrasive blasting. We revealed over 900 holes throughout the upper 1/3 of the tank. All of those holes had to be patched and repaired prior to installing the tank wrap system. So the tank wrap system was fully installed. It was inspected to make sure there were no anomalies in the installation. If there was something found, it was identified, recorded, and then repaired. Once we went through the entire list of repairs and inspection, the client elected to use their top coat and ended up painting right over tank wrap and, in fact, putting their logo right over the top. It was a great installation. All the QC checked off. And about 2009 or so, they called us and said, hey, this tank is actually doing really well. We don't have any signs of leaking. We don't have any signs of deformation or buckling. How long could this thing last? And we reviewed the project file and said, look, if you are arresting the internal corrosion and we do, some inspection and maintenance every 3 to 5 years, this thing's going to last over 20 years. And next year, in fact, it'll be turning 20 years old. So that was
And it's still in service?
Still in service.
And so we're actually still in touch with the customer there. And actually this past year, they found they had to go back and do some work on it. And he called and said, Dominic, I have one regret about the project. We didn't do the roof. But now they're finally having to go back and replace the roof of the tank. But, after getting their 3 years and then getting another, plus 17 on this, they're very happy with the return on investment, which started to pave the way for us being involved in tanks and things like that to help people find this new option that they weren't aware of. And 20 years later, people still aren't that aware of this option. So yeah, it's been quite the experience working with that customer over the years.
Well, if it's any consolation, I remember introducing customers to composite repair on pipe in 2003, 2004. In those days, our engineering package was an Excel spreadsheet. Right. And for those who listened back then, with just training, surface prep, good calculations and good planning, those jobs went well. But 20 years later, we now have tons of, back then, as you pointed out, PCC2 was not in place yet. AB 539 wasn't in place. API 653 wasn't there. And all of those recognitions from all those different authorities have all been vetted with tons of contingency and planning and consideration. And so, I think, and there's still clients out there who don't know what they can do on piping. And I think, particularly, even more so, there's an entire industry of people out there who are managing and inspecting tanks who likely don't know that this is possible. So I think this recording and this podcast will hopefully allow us to spread the word together more on what's possible for the 2024 upcoming tank repair season. I think this has been a great conversation. What's next for HJ3? Like, where are you taking carbon fiber next?
Yeah, so we're going to continue focusing on what we're good at. So our visionary, Jim Butler, set out a really good agenda, which is be the number one in the markets that you desire to compete in. And that's what we're doing. We're continuing our company initiatives on, the strongest ply product in the industry. So there's ongoing innovation with building stronger products. Most of our work is going to be like you, Don, out there educating people, making sure they know about this type of repair technology and setting a forum for them to express concerns, objections, and working together to satisfy those technical concerns. So that's really what we're focused on, taking advantage of the opportunity in these markets to help owner operators really get this type of technology so they can get from where they are now to their goal. And we're really blessed and fortunate to be part of that mission.
Awesome. I love, you guys operate on EOS. We operate on EOS. So I love the common language that we use, and I hadn't heard this part of Jim's vision about be number one where you want to be. We have a cultural standard that says we want to be number one and leave the rest. And so every time we talk, I learn more about the synergies that our two cultures have in our businesses. So it just makes me smile every time we chat. So now, for everyone listening, how do they reach you guys? Like what's the website? What's the phone number when customers around the world want to reach out and ask for help?
Yeah, so our website is www.hj3.com. You can reach us at 520-322-0010. That's our corporate office in Tucson, Arizona. You can email us info@hj3.com. Let us know what you're interested in. We do provide technical webinars and educational webinars to get your group familiar with the technology. And we can start the conversation there, see where it goes, and start addressing needs.
Yep. We're also putting out a lot of insights on LinkedIn. You can find Ollie and myself there, and the HJ3 page on LinkedIn as well, to get information on current projects, updates, news, things like that about the company and the team.
Fantastic. We'll make sure our team put all of the contact information in the show notes. If you're in Canada, we are Innovator is HJ3 partners in trying to grow this in Canada, and you can obviously find us on innovatorind.com. And one last thing for listeners out there, you'll probably be listening to this after our next event. So in less than 2 weeks, Ollie and Dominic are joining me again, and we're doing a live webinar. If you may have already seen it, we're starting to invite all of our clients to that webinar starting this afternoon. But by the time you hear this podcast, it might be in a month or 3 months from now. In addition to this, if you like to dive into the details and you want some visuals and you want to hear some Q&A, then go to the Innovator or the HJ3 website, and you'll be able to find a re-recording of our webinar together coming up here shortly. So with that, guys, I really want to thank you for coming on to the podcast and having this chat for an hour. Really appreciate it. Look forward to us doing the webinar together in a couple of weeks. And I guess that's it for now, folks. Everyone listening, thanks for tuning in. And if you've got a tank and you want to think about a different way of dealing with it, reach out to us. Bye for now.